Hey everyone. So we're now looking at equations of motion. So looking at this example, we're given a 10-pound block travels with an initial velocity of 10 feet per second on a smooth plane. The time variant force acts on the block for 3 seconds. We're told to find the final velocity of the block and the distance it has traveled in this time. Alright, so looking at this picture and giving this information, we'll go with a free body diagram. Here we have the block, and then we have the 10 going down, a to the right. We have 8t squared coming in from the right. Down here we have that f sub f, that's 0.2, and then we also have, I'll just put it right here, that n right there. Alright, so looking at the equations of motion first. Alright, so we have the sum of the forces in the y direction. Alright, we're inputting n minus 10, and for us that should be equal to, what do we have here, the 10, and of course it's over 32.2, and then it's times 0. So all I did was just substitute in, and now that's solving this using a little bit of algebra. We'll get our n is equal to 10 pounds. Alright, and I'm gonna go down here and use the sum of the forces in the x direction. Alright, and then go ahead and substitute in as well. So on the left hand side we have 8t squared, right, minus 0.2 times 10. Alright, and then that's equal to 10 over 32.2 times a. Alright, solving for a, we go ahead and get 3.22 times 8t squared minus 2 feet per second squared. Alright, so just to clarify a little bit further in the beginning, maybe it might have helped a bit. The friction is mu sub k times n, right? And that's equal to 0.2 n. So I use that information. Alright, so we have our a value. So we did the equations of motion. Now it's time for the kinematics. Alright, so the velocity of the block as a function of t can be determined by integrating dv is equal to a dt. Right, we can, again, the velocity of the block as a function of t can be determined by integrating this right here, dv equals a dt. So using the initial condition of v is equal to 4 feet per second at t equals 0. Alright, so let's go ahead and write that out. So from 4 feet per second to v. Alright, what do we have? We have 0 to t, 3.22, 8t squared minus t dt. Alright, then we'll have v minus 4 equals 3.22 8/3 t cubed minus 2t. Alright, and then go ahead and we get v is equal to 8.5867 t cubed minus 6.44 t. That's plus 4, and that's feet per second. Alright, and then we can say lastly when t equals 2 seconds. Alright, so when t equals 2 seconds, v equals 8.5867, and just plug in that 2 in for t. So that's 2 to the third minus 6.44. T is 2 plus 4. Just crunch some numbers a bit. We get 59.81 feet per second. Let's take a look at another example. So we're given that the motor winds in the cable with a constant acceleration such that the 20 kilogram crate moves a distance s equals 6 meters in 3 seconds, starting from rest. Mu sub k is equal to 0.3. So we're told to find the tension developed in the cable. So here's our plan. First, we're going to draw a free body diagram. We're going to draw the free body diagram and the kinetic diagram as well of the crate. Then we'll go ahead and use the kinematic equation. So we'll use the kinematic equation to determine the acceleration of the crate, and then we're going to apply the equations of motion to determine the cable tension. Alright, so let's go ahead and start. So as far as our solution, let's say we'll draw the free body diagram and kinetic diagrams of the crate. If we take a look at it, it's going like this. I'll have the X right here and the Y right there. And this is at 30 degrees. That's given. Okay, so now I'll make the crate, and for the crate we have at T N, we have coming down like this will be W, and it is said that that is equal to 20. Okay, and then we have that F sub K, and I believe that was 0.3. That's 0.3 times N. Alright, so since the motion is up the incline, we rotate the XY axis so the x-axis aligns with the incline. So then motion occurs only in the x direction. Alright, so next, using the kinematic equation, we have S equals V sub O T plus 1/2 at squared. All right, let's throw in here the picture again. I'll move it over some. Okay, so looking at this, we have constant A, right? Constant A. We have S being equal to 6 meters, we were told, at t equals 3 seconds. B sub O is 0 meters per second. Okay, so in the kinematic equation, we'll have 6 is equal to 0 times 3 plus 1/2 A, and then the t is 3, and we square that. Alright, so then solving for A, we get A, sorry about that, we get A is equal to, solving for A, 1.333 meters per second squared. Alright, next applying the equations of motion. Alright, so here's how it'll look. So we say positive is in that direction since we rotated it. The sum of the forces in the y equals 0. So that gives us negative 20 g times the cosine of 30 degrees, right? Plus n equals 0. Alright, then we get from that n is equal to about, crunching that, 169.9 n. Alright, and then we'll sum up the forces in the x, and it's in that direction according to what we've drawn. So sum of the forces in the x. Alright, so for us that's going to be t minus, so that should be t minus, that's the minus 20, right? T minus 20, and this time we multiply it times the sine of 30 degrees. Times the sine of 30 degrees. And then minus 0.3 n, and then that should get us, we should say it's equal to 20a. Alright, and then we go to t is equal to 20 times 981 times the sine of 30 plus, I'll just take it down here a little bit, 0.3 times 169.9 plus 20 times 1.333. Alright, and then lastly, T comes out to be 176 newtons. Okay, looking at this next example, an ore car's mass is 400 kilograms. V sub O is 2 meters per second. The force in the cable is F equals 3200 T squared. N, where T is in seconds, assume there's no friction generated between the wheels and the inclined surface. So we're told to find V when T equals 2 seconds. Alright, so here, since we're looking at this problem and there is forces and velocity involved, we're going to use kinematics and equations of motion. So looking at this, I would draw really quickly. And 3200 t squared. Then there's the 400, right? And then we do it times 9.81. And then don't forget that triangle that we have to make there. It's given way over here, the triangle, that special triangle, 8, 15, and 17. Alright, so in coming up with a solution, what we'll do, seeing that it's running in this direction, we'll call that the positive direction. So we say the sum of the forces in the x is ma sub x. So that makes it 3200 t squared minus 400 times 9.81, and that's times 8 over 17. And you see how some of these problems give you the degree measurement of the angle, or sometimes they'll give you the special triangle, and you have to use that. So that's equal to 400 a. Alright, so then solving for a, we get a is equal to 8t squared minus 4.616. Alright, and then using dv equals a dt, integrating 2 to v, dv equals from 0 to 2, it's 8t squared minus 4.616 dt. Alright, finishing that out, we'll get v is equal to 14.1 meters per second.